I'm Ellis Martin. Could sodium chloride or salt-based solid-state batteries replace lithium-ion batteries or add to the choices for energy storage? Might these batteries be the perfect solution for grid storage? We're going to find out today. Join me now as we take a virtual trip to Perth, Australia to visit with Iggy Tan, the Managing Director of Altech Batteries Limited, trading as ATC on the ASX. Altech Batteries is commercializing a 100 megawatt hour solid-state sodium chloride battery production facility and is also at the cutting edge of developing battery materials for a lithium-ion battery future by successfully incorporating silicon in graphite anodes to produce higher energy density batteries. Mr. Tan is a highly experienced mining and chemical executive with a number of significant achievements in commercial mining projects, such as capital raisings, funding, construction, startups, and operations. Mr. Tan has over 30 years of chemical and mining experience and has been an executive director of a number of ASX-listed companies. Iggy, welcome to the program. We love having you on the air with us. Thanks for joining us today.
Hi, Ellis, and thanks for having me.
It certainly is a pleasure. I want to start off right away in this conversation with a bit of a complaint. It's not about you. I bought a beautiful Tesla Model S Plaid 2 years ago, and by gosh, if the charging situation is not what was promised, the range is terrible. And I think if I had waited 2 or 3 or 4, maybe 10 years or so, I'd get better value for my dollar as it is. Now, what are you doing with Altech Batteries to really change the dynamic with regard to lithium-ion batteries and that technology?
Yeah, thanks for the question, Alice. But our batteries are actually sodium chloride or salt batteries, but they solid state batteries. So just to give you a background of where lithium ion batteries are heading to. So if you understand the problem with a lithium ion battery, they tend to catch on fire. And once they're on fire, it's called thermal runaway. And it's very difficult to put the fire out because it generates oxygen at the cathode end of the battery. So the industry is trying to go to solid state. Essentially, they're trying to remove the liquid electrolyte in a lithium battery because that's flammable to a ceramic piece, which is called solid state technology. So I don't know whether you've heard of solid state technology, but essentially that's what they're trying to do with lithium ion batteries. Our batteries are the solid state technology, but we don't use lithium. We use sodium chloride, which is common table salt. But unfortunately, we're not looking to make batteries for your EVs, Alice. We think the bigger market is in the grid storage market. The grid storage market is growing at 28% year on year and expected to have about 150 billion invested by 2035. So a big industry growing, and that's where we're targeting.
Fair enough. I can certainly continue the conversation with regard to batteries for EVs, and I want to, but let's dig into sodium chloride batteries and talk about energy storage. We can generate energy in many, many ways, especially here in the Western US, Australia, some parts of Europe, Africa, and what have you, but storing energy is the biggest problem. How do you store it, keep it, maintain it, make sure it doesn't lose its density, and preserve it? And you're saying the answer is salt. Is that extremely economic?
Let's talk about the grid storage. You are correct. There's a lot of green transition energy providers coming on stream. So solar farms, wind farms, etc. But they haven't resolved the problem of storage because technically you're generating power during the day when the sun is shining, but at night you don't store that power so that you can use it at night. So you haven't solved the main problem. So grid storage is very important. Essentially, you've just got a whole bunch of batteries on your grid so that during the day when the sun's shining, you can charge those batteries. And at night, you can discharge the batteries and provide power 24 hours of a day. So it's called energy shifting. And the battery storage business today includes lithium-ion batteries. They tend to be more the lithium iron phosphate batteries or LFP batteries. This is probably your battery that Tesla is going to use in their future cars because they don't have cobalt and nickel, which is very expensive material. And they're also safer batteries than the nickel cobalt batteries. So the grid storage have these kind of batteries, LFP batteries. They got vanadium flow batteries, but we're providing an alternative, which is essentially a sodium chloride solid state battery. So the technology was developed by the Fraunhofer German Battery Institute out of Germany, and we have a joint venture arrangement with them to commercialize that technology in a 100 megawatt plant that we're building in the east part of Germany. So the main message is that we didn't come up with the technology. The German Institute has spent nearly 35 million euros over the last 8 years developing this technology. And our job is to commercialize it, and that's what we're planning on.
Essentially, you're almost the end user. You're vertically integrated. You're developing the process, engineering the process, mining, and taking it to the end user. Explain the vertical integration if you don't mind, because I'm fascinated by this.
So essentially, our technology is using salt. So it's essentially a ceramic tube filled with salt and a nickel metal powder. There's a positive probe in the middle, and it sits in a metal canister. So that's the battery itself. Now, when you charge the battery, the sodium ions migrate through the ceramic tube, and it forms molten sodium on the other sides. When you discharge the battery, the molten sodium discharges back through the ceramic tube, grabs the chloride, and becomes salt again. It's very similar to a lithium battery. Instead of lithium, it uses sodium, and sodium is actually a very reactive material. If you remember your periodic table in your chemistry from high school, Alice, sodium is just under lithium, so it's very reactive. But the best part of sodium, it's freely available, so it's just common table salt. Now, if you think about lithium batteries, what goes into a lithium batteries? Very expensive critical minerals. Lithium. Now, the price of lithium has gone up fivefold in the last 2 or 3 years. And that's put a lot of pressure on the lithium battery industry from pricing. Cobalt goes into lithium batteries, and there's concerns that ethical supply of cobalt, because 70% of cobalt in the world comes from the Republic of Congo, and there's issues with child labor and workplace issues. So that's a concern for the lithium-ion battery industry. The other thing is also graphite. 90% of graphite comes from China. So imagine one country providing all that material for all the batteries in the world. That represents a geopolitical risk. Then you got things like copper. There's 2.5 times more copper in your EV than a normal petrol car engine. And there's reports that say that there's not even enough copper mines being developed to just meet the EV demand. So that's another concern. And so because of all these materials, our battery is a real benefit is that we don't use lithium, we don't use cobalt, we don't use copper, we don't use graphite, we don't use manganese. We just use common table salt and nickel metal powder, which is also in lithium batteries. So that's our main advantage. It's going to be about 40% cheaper to produce these batteries, and that's what the world needs. The world needs cheaper and cheaper batteries.
I don't think that any of our friends in the mining sector that are in the business of mining or developing projects that include lithium or nickel or copper or cobalt would be very happy with this conversation that we're having right now.
I beg to differ, Alice, because we need all types of batteries in the world. The lithium battery is a great battery. I was at a mining club event last week, and I was on the panel talking about critical minerals. And I made the statement that mining has to increase about 1,000% to meet the green transition. So as the world moves to renewable energy and the green transition, mining has to increase 10 times. And yet around the world, people don't want mining. You have to understand that the mining is actually the key to the green transition. I made a statement, you might love this, Alice. I said to the audience, who has an electric vehicle in the audience? And people put their hands up. And I said, do you know that on day one receiving your electric vehicle, you have double 200% the carbon footprint than a normal petrol engine? And it will take you 10 years before you are the same point as an ICE vehicle. And then you get better from that. So a lot of people were shocked because they didn't realize that just because that getting an EV car, yes, it's great. And I'm all for EV cars because I'm more interested in the pollution reduction, because EVs take out this fine particulate pollution that's causing health effects and the climate changes. So all for green EV cars, but people got to realize that your carbon footprint is actually double and you need more mines to make it happen. Are you familiar with your carbon footprint for your
Absolutely.
your Tesla?
Absolutely. Yeah. I rushed into buying the car because I'm in the same business as you are, not exactly, but as a journalist. And I thought I needed to represent. So I got rid of my car collection, which consists of internal combustion engines, and I bought a Tesla. And I was very excited about it. Then I thought, wait a minute, knowing what I know about what you just said, I've doubled the carbon footprint. I'll never get the value that I personally paid for the car. I'm not going to be a polluter, but that carbon footprint on the way to it becoming a car that lives in my driveway right now, I didn't do anything for the environment by buying the car. I didn't do anything for my pocketbook, and now I'm not getting the range. And the technology will continue to evolve as far as battery metal chemistry.
And also the electricity you charge the car is also important. Where does that come from? If you're generating in Australia, we can generate power from our solar panels. Australia is one of the only countries, one of the leading countries where domestic houses are generating their own electricity from solar panels. That's great. You actually then in the right area where you're using renewable energy to charge your EV, which is perfect.
Is this a proprietary technology that you have? Will you become a platform technology if it is and make it available to everyone? Because I see this as something unique as a potential investor. Why should we get involved in Altech? I've heard a lot of good reasons right now. Give us some more.
Yeah, the technology is actually developed, as I mentioned, with Fraunhofer Group. We in a joint venture where we own 75% of the joint venture, and we own the technology. Essentially, the joint venture owns the technology worldwide. Our first project is a 100 megawatt plant. The product that we produce is a 60 kilowatt battery, and it goes into a sea container, which is about a 1 megawatt sea container. It's designed that you can deliver to the site very simply, drop it on deck, plug and play, and suddenly you got 1 megawatt connected to your grid. It's very much the same as the Tesla Megapacks and so on, but much more robust. The battery technology is quite different. The battery itself operates at 270 degrees internally. It's fully insulated so that you can touch the battery on the outside with your hand. But like a mammal, it controls the temperature by charging and discharging. So essentially, when you discharge the battery, it creates heat. When you charge the battery, it's endothermic. It absorbs heat. So it sort of looks after the temperature of the battery itself. And that's the reason we don't have any cooling fans on the battery itself. So if you take a Megapack or a big battery, there's probably about 260 cooling fans trying to keep the battery cool, and probably 2 air conditioners in the structure of the battery trying to keep the battery cool. So in your Tesla, most of the management is trying to keep those batteries cool. We don't have that problem. So because we don't have that problem, this battery can sit in a wide range of temperatures. So we can operate down to minus 40 degrees. You can drop this battery in the snow and it'll operate at minus 40 degrees. You can drop this battery in the desert at 60 degrees Celsius, I'm talking about, not Fahrenheit, 60 degrees Celsius, and it'll operate. Whereas a lithium-ion battery has very limited temperature range. They only operate around 15 degrees to about 35 degrees. If you get to very cold climates, your batteries actually slow down. And that's because the liquid electrolyte becomes more viscous. That's one of the other advantages we have. We have a wide operating range. And then finally, we have a much longer life compared to lithium-ion batteries. Our sodium ions don't degrade every time we charge and discharge, so we can get beyond 15 years life. So these are the other benefits of our batteries.
How does it compare weight-wise to a lithium-ion battery that might be in an EV? I remember earlier in a conversation, it wasn't really about EVs, it was about other applications. I keep leaning toward them. So tell us about it.
The weight to volume ratio is slightly heavier than the LFP battery. So we strategically didn't want to get into the EV business. It's a very competitive business. You're talking about, we want to get into an industry that is nascent, that is growing, potentially growing very fast, and get into an industry that we can start off and start to dominate that industry. So that's where the grid storage market is. So we are targeting the grid storage market. Just to give you some background of some of the challenges of grids, Alice, in a normal cities where you are, your demand of power goes up at 6 a.m. in the morning because everybody gets up in the morning and they start cooking their toast. The demand then drops during the day, and then it goes peaks again at 6 p.m. where everybody returns home and they start cooking and they're putting on the TV and so on. So peaks in the morning and then it peaks in the evening. Now let's look at solar generation today. It generates power during the day when demand is less. At 6 p.m. when the demand increases, solar goes down because the sun sets. So the electricity suppliers have a big problem trying to manage this because at 6 p.m. demand goes up, your supply goes down. They have to bring power plants on just to meet that demand to 8 p.m. where everybody then start to go to sleep. So it's actually very inefficient to bring these power plants up and running for just short periods of time. There's a lot of costs involved. And so the idea that utility suppliers can have a bank of big batteries onto the grids, they can actually charge it during the day and then just discharge it for 2 or 3 hours at night just to maintain the demand. And that's why the grid storage or the utility suppliers are very interested in these big batteries to stabilize their grid. Now, the other issue, Alice, is that with solar panels, what happens when there's a cloud cover? Suddenly your demand drops. Well, the electricity suppliers have to have standby power plants ready to meet that short-term demand, and that's very inefficient. So if you had batteries in your system, you can actually discharge it to the grid and maintain that supply. And then finally, the other big issue is frequency drops. So power drops very quickly. You need the ability to just maintain the frequency. And big batteries are the ideal solution for that.
At what point does the company become profitable, and when are we going to see them everywhere? Since you're not having talked with car makers for the automotive industry, you must be having conversations with the utilities. And has that started now? And will you be partnering with them? Will they be investors in the company? Explain some of the financial fundamentals as you answer my question, if you don't mind.
Yeah, we are currently in the final stages of completing a definitive feasibility study. And essentially that will give us what the capital cost for this first 100 megawatt plant will look like. We then go to the funding of the project. The funding will be in 3 components. The first component is grants. Like the US with the IRA Act, in Europe, there are a lot of money that is, destined for this sort of green project. We will then follow up with a debt component and equity component. So to answer your question, yes, we are talking to a major utility supplier in Germany. They have to bring on about 8 gigawatts of solar or renewable energy to come on stream, and they're interested in all kinds of batteries. That is our first port of call. One customer to take most of our batteries of the 100 megawatt plant for 5 years. That's the aim. Once we get this plant up and running, we will then be looking to actually get into the real production of batteries for possibly a 4 gigawatt factory. Now we're getting into the gigawatt style factories, and obviously Europe is a great place to be, and obviously the US is probably the next port of call as well. So we're open, and we will start to work with some of the bigger groups because we probably can't just roll this out ourselves. We own the technology, and we're happy to have partnerships or joint ventures to develop this technology worldwide, because essentially the world needs more types of batteries, more batteries and more types of batteries.
Well, Iggy Tan, it's been a pleasure chatting with you. I have many more questions, but since we're going to be together for several months, I'll leave it for our next interview. Thank you so much for joining me today on the program.
Thank you for having me. I've enjoyed it.
I've been speaking with Iggy Tan, Managing Director of Altech Batteries Limited, trading on the ASX as ATC. Visit the company's website, altechgroup.com. Questions, comments? Head to our website, ellismartinreport.com. I'm Ellis Martin.
Subscribe to the Ellis Martin newsletter. It's free. Go to ellismartinreport.com and fill out the quick and easy pop-up form.